220, right? But then we didn't touch anything on 221, so we can start there. That is the exponential ones. So ln of the base, leave the function the same, derivative of the exponent. 21, we did all of 222, anything 223. And then 224, 225. Those are all really good. Let me write them down. So I think that's not, well, close enough. 221, 223, 224, and 225. I think that's going to be good practice. And after careful consideration of the options, I have decided that Monday of next week, this coming Monday, will be a day of review, and Tuesday will be the quiz. Okay, that's the plan. I'll put together a little something. Obviously, the quiz will be relatively short because it's just during a 15-minute class. So I'll try to design the quiz to be the practice, the review on Monday to be a little bit longer, so you get like a couple of each kind. That's what I'll do. I'll put the solutions together and everything. So I'll have that for you ready to go. And then probably we'll go like Wednesday, Thursday, Friday will be any See You Succeed trig stuff. Okay, the things that I haven't taught you, some review, and then Friday will be the actual See You Succeed trig final, which is 13 questions, all multiple choice, pretty easy. So I think we can do that on a Friday. That would be more than 2 minutes per question. Like, actually, no, it's 3 minutes per question, which is, I think, plenty. So that's the plan for next week. Okay, Monday review with exponentials and logs. Tuesday quiz. Wednesday, Thursday, like learn and practice and be ready and do whatever we need to do. I'll have a little review for you for that as well. And then Friday, we'll actually sit down. Here's what I think I want to do, though, to make it fast and easy for you. I'm actually going to run the quiz through Canvas for like how you fill it out. I'll print it out. You can write all over it, but you'll actually like put your multiple choice answers into a Canvas quiz so that it gets graded right away. That'll just be super, super fast. For me on my end, it's good for my bookkeeping too, because I have to keep track of who got which questions right, who got which questions wrong, how did we do collectively on certain questions, and that would save me about 2 hours of data analysis. So spend 30 minutes to make the quiz to save me 2 hours. I think that's a good idea. So plan on bringing your laptops with you, your devices with you on Friday, a week from today, for sure. Okay. If that's an issue for you, of course, let me know. If you really prefer not to, you don't have to. Okay. If it's going to impede your chances, you can do it by hand. That's fine. I will just import it separately. Okay. So it's not a mandatory thing, but if you're okay with it, it's going to save me a whole lot of time and probably save you a little bit of trouble. Okay, so 221, 223, 224, 225. That also will give the people at home kind of the same chance to do it. So I'm going to work through these. You can do the same, starting with 221 and seeing how those go. You don't have to wait for me. You can just kind of peek up at the solutions as you go and then kind of move on. And we'll go from there. Of course, if you have questions, stop me, slow me down. I'm just going to do this one first. I'm going to blow this one up. Because it looks like we've got ourselves a little product rule going on here. Plus, we've got trig, what looks like the chain rule inside a cosine there. So we got a whole bunch of things happening. But I don't know. I just felt like giving us one more day to like lock these ideas in, especially like after a weekend. Refresh our memories a little bit after a couple days off. So hopefully that sits well with all of you. Here I go. Listen to music, talk to each other, talk to me. Whatever works for you. 9:45, we're at here. 10:25. Yeah. There's one way to go find out. Go ahead, let's take a look. In fact, you want to give me something? Anything that has coffee in it. Just like a regular coffee or like a mocha latte. Coffee and chocolate combo. Here's $4. By the tallest, biggest, most caffeinated thing you can find. Also, if anybody wants, you can go. You're good. If anybody wants, the science classes have been making some caramel, and my students brought me some. It's soft and delicious. Come help yourself if you want. Exponential, different base. ln of the base, leave the function the same, derivative of the exponent. Ooh, this one's crazy. Chain rule here. I'm going to pull out what's common. It's like negative 2 negative 2 plus didn't get much trickier than that one. What's that? Oh, okay. I guess because of the Friday late schedule. I guess that's. Oh well. That's funny. I do like caramel. You gotta have it. Help yourself if you want. I'll leave that up for another moment or two, and then I'll put down a 2 on the bottom. Put a little quotient rule on. That's a really, really good question. I don't know where to go. It should be right here, right? LM2, terrible. You're right. It's hard to keep track of all this. Send that out. Natural log. So because I pulled out the negative and 2 to that, so I need the natural log of 2 cosine of phi theta. Thanks for catching that. So here, natural log of 2 cosine of phi theta. This, that, there. Thanks. How close is hard? It's a lot to keep track. Yeah. And I chose to pull out the negative because I saw it was common in both, and that just makes it nice to pull that up front. You didn't have to do it this way, but as soon as I see a negative exponent and it's something that's in common everywhere, which anything exponential always will, because part of the derivative is just leaving it the same, you're always going to have that common factor. So factoring that out, I just made like writing it as a single rational function so much easier, rather than leaving it as 2 separate ones all over 2 theta, or 2 to the theta. And I went with f prime of theta, but if you wanted to go with the with Leibniz's notation instead, which is something I want to keep doing because it's going to come up a lot in chapter 4, it wouldn't be dy dx. It'd be dy d theta. Derivative of y with respect to theta. So that's the only variable in here. And once we get to a week from Monday, we start chapter 4. We'll be looking at finding the derivatives of things that aren't functions. So I can't get it in terms of y necessarily as a function of x. We'll take dy dx, because that'll be our independent variable, but we're going to have y's and x's kind of all over the place. We'll have to keep track of that. That'll kind of be our last strategy. We've been defining the derivative explicitly in terms of x. We're going to have to do what's called implicit differentiation instead of explicit. So good. It's a dewy ball of sugar. So good. All right, there's that one. Moving on. Quotient rule. We ordered it anyway. There. Factor out the 3 to the 5x if you want, but it's not going to do us much good. Factoring here is going to help me simplify. Pull out 2 to the 3x. Here, pull out 2 to the 3x from here. Let's do it one. Bottom way. So a couple good ones here for sure. Just practice with the quotient rule, and then had a couple things going on with exponentials. Second one ends up being further simplifiable, I guess you could call it, because the denominator is where the exponential thing shows up. So that's going to show up in every part. It's going to show up in VDU, it's going to show up in UDV, and of course, it's going to show up in V squared. So that common factor of 2 to the 3x is going to be everywhere, which is what allowed me to pull it out up top, kind of visually separate it just for my own benefit. I like to do that. You don't really have to. But you see, I left it factored, the 2 to the 3x squared, rather than calling it 2 to the 6x. Allowed me to factor and pull it out a little bit easier. Again, this is pushing the envelope for sure in terms of difficulty. This would certainly be the hardest kind of question like this that I would ever ask of you on something like Tuesday. The chances are it might be a little bit easier. Then again, this is monomial and monomial, so it's not too bad. But hopefully, even if you didn't get this on your own, it's something you can follow, right? The kind of thing that maybe you take a picture of now before I erase it, if that's what you need, and then kind of come back to it and see if you can recreate it, put it together. I think learning calculus is about being able to follow it first, recreate it if you need to, and then do better as you go. But I'll tell you what, I care way more about the calculus than I do about the algebra. Factoring and simplifying and writing it as nicely as you can, that is going to be worth significantly less than your ability to like properly set up the quotient rule or whatever the case may be. Right, those first few steps, that's 70 to 80% of the points is going to be UV, DU, DV, and then just step number 1. That's the big part for me. You set up what you need to, you apply whatever the rule is correctly. How you simplify from there, those will be, that's just going to be the difference between a B and an A. Okay, so one more minute of me leaving that up there, and then I'll switch it up. Of course, folks at home, let me know if things come up, if you have questions. Like I said, the quiz will be on Tuesday, and I'll just put it on Teams. Or you can come in. That's cool. All right, next page. I guess skip a page. Skip a few. Oh, what about this one? Ooh. I like anything that starts off like that. What values of x? Would the graph of that have a normal line whose slope is 2? Okay. So if I want to have a point, let's say an x value, whose slope of the normal line is 2, I want their tangent line to have a slope of -1/2. That's kind of my first thought. Get me back to a tangent line, because if I can find p prime, let's see, ln of 2 e to the -3x times -3, so let's call it -3 ln of 2 over 2 to the 3x. That's my derivative. What I really want to happen, oh, I haven't done this one yet. This will be fun. I want to take this and set it equal the tangent line's slope that I want. So I don't set it equal to 2 because that would be the normal line. What I'm going to do is I'm going to set it equal to -1. I'm going to solve it somehow. Now, with the variable being stuck in the exponent, solving exponential functions, something you learn in Algebra 2, turn around, it's literally what I'm doing in my regular Algebra 2. Not Algebra 2 trig, not Algebra 2 trig honors, regular Algebra 2. You want to solve an exponential equation, you need logarithms. The only way to do it. So I need to isolate the 2 to the 3x, and then I'll switch it to logs. So that's going to continue over here. Let's drop the negatives first. That'll make things a little bit easier. And cross multiply. So we get 2 to the 3x times 1 equals 6 ln of 2. Now, lots of different ways to go about this. You could take the log of both sides. You could take the natural log of both sides. You could change it into log form, which is what we do in Algebra 2, regular Algebra 2, is going to make the switch. A lot of different strategies here. You'll see in calculus a lot of time we just take the natural log of both sides because the natural log works out so nicely. Let's try that. Let's take the natural log of both sides. So I'm going to do ln of 2 to the 3x and ln of 6 ln of 2. Why do that? Well, properties of logs say take that exponent and drop it in front. 3x ln of 2 equals ln of 6 ln of 2. And divide. Voila. Yuck. Whatever that is. A lot of different ways to do it, but taking the ln of both sides is a very good calculus strategy. But I could have just like switched it one to the other. This is, again, pushing the envelope a little bit. I probably won't ask a question quite as tricky as this one, if I even ask a question like this. We'll see. When I design the review this weekend, you'll have a sense of what you need to be able to do Tuesday once you see what number it is. I think that looks good. So equal to the slope of the tangent line that I want. Drop the negatives, cross multiply, ln of both sides so I can isolate the exponent, and then just divide by the constants that are over there. The ln of 6 of ln of 2. I wonder if there's something there. You could simplify a little bit. Can't cross out the ln of 2's. It's not being multiplied top and bottom. The ln of 2 is kind of stuck inside the other natural log. So can't really break that out. ln of the ln. So, I don't know. Properties of logs. Ln of the ln of. Kind of like composition. Wonder if that's nicer somehow. I can't think of it right now. If it is like the natural log of something exponential, those would just cancel each other out and just be left with the argument. But natural log of the natural log of something is, I don't think there's much. That's where I would end. That's a funky one. And you'll see as you get to AP next year, if that's something you do, or if you take Calc 1 next year if you're graduating, these are the kind of things that they like to do more and more of. Not just here, find the derivative, find the derivative, find the derivative. Let's actually like focus in on a part of the function, see if we can isolate some things. Can you apply your derivative knowledge to questions that maybe aren't like exactly directly asking you to find the derivative? They had to know a little bit about the normal line to be able to set it up correctly. Of course, needed the derivative. But then you need the algebra, you need logarithms, you needed all that pre-calc and algebra 2 knowledge. I don't know how much you did last year with solving exponential functions like this. Maybe you solved them like that, right? You isolate the base and the exponent algebraically, and you make the switch to logarithms. I actually find it a lot more comforting, I don't know, to like just take the log of both sides. And another option here that I think might have been, ooh, you know what? I got another idea. Instead of taking log base e of both sides, let's take log base 2 of both sides. I want to see what happens there. I wonder if it's a little simple. First, though, I want to see what that constant is. Let's see if I can get the same answer. Yeah, and I have never done this problem. This is kind of cool. Okay. So, ln of 6 ln of 2 divided by 3 ln of 2. It's a little less than 3, 2.96. 2.96, 4 decimal, or 3 because we're in calculus, 964. Let's see what happens if I back the truck up a little bit. I'm going to go right here. And we take log base 2 of both sides. And I'm doing that because the base is 2. That's my exponent attached. And that'll hopefully get rid of all of the ln of 2's that I have floating around out there. Let's take log base 2 of 2 to the 3x and log base 2 of 6 ln of 2, because log base 2 of 2 to the 3x is 3. 2 to what power is 2 to the 3x? 3x. Whatever this is. Ln of 2. Because now I can just divide by 3. I'd probably put like 1/3 maybe. Here, so it's obvious. Let's see what that is. Okay, to find log base 2, it's math. And then down to log base. Log base 2 of 6 ln of 2. Close it, get out. Divided by 3. That's not the same. No, I don't know why I got the thing. Did anybody else do this one? Get anything like I did? Maybe I'll come back to it. I'll try it with fourth period too. But don't sweat it. It's not something I would put at you. That's that difficult. I could do a much simpler version of this. for sure. Let's try some of these. 223. 5 minutes left, so let's see if I can get at least one of these done. Base 7. I haven't done this one yet, right? X squared minus 1 to the 1/2. And I'm going to do, for sure, this nice little property of log. So I don't have to worry so much about the chain rule. It's already going to be the chain rule, which makes it a little bit easier. There's K. Now let's find K prime. 1/2 times whatever the derivative of all of that is. Derivative of a log is rational. I have to like say this stuff out loud or up on I never derivative of the inside, I think, goes up top, right? And then ln of the base times x squared, the inside. 2's will cancel, that's nice. 1x, just x over ln of 7, x squared minus 1. If there was any factoring that was worthwhile, like x plus 1, x minus 1, I would definitely do it. Trying to simplify things out. That's pretty good though. I pull that constant out in front. Properties of logs just makes it a bit easier to get yourself to the same answer that you would in case you didn't. And of course, rewriting that with that exponent was crucial so that I could either make the change or recognize the chain rule. Yeah, that looks good. I like that. Maybe one more. Q prime. It's a log, so it's going to be rational. The derivative of the inside goes on top. I'm going to save that here in a second. On the bottom goes the ln of 3 times the original. To find the derivative of the argument that 3x over x minus 1, that's a quotient. I need the quotient rule to do it. So we have this smaller fraction up here. B, x minus 1, du minus u dv all over v squared. X. All right, complex fractions. Time to simplify the top. Simplify the bottom, and then put some things together. So it looks like a big fraction down the middle, smaller fraction up here on top. 3x minus 3 minus 3x over x minus 1 squared. And then 3 ln of 3x over x minus 1. Okay, I just tried to make like one fraction on top, one fraction on the bottom. The top is nice. It'll just simplify to -3 over x minus 1 squared. This is 3, nothing to do down there just yet, over x minus 1. I distributed the x minus 1 into that 3. Because it was v du. So v was x minus 1, du was 3. So ln of 3 is right here, right, over 1. So I'm multiplying fractions, so I just multiply straight across. So 3 ln of 3x, and then 1 times x minus 1. Now, I want to turn this not into a complex fraction. I want to take this right here and make one fraction. And with the whole keep, change, flip idea, really what I can do is I can like divide the numerators and divide the denominators. That's going to go away. That's going to become a 1. Those 3's will disappear and become 1s. So what I've got left looks like negative ln of 3x over x minus 1. Woo! That's a good one. Like that one, Siggy? Funky, right? All over the place, yeah. Yeah, last section in unit 3, derivatives of logs and exponentials. Yeah. These rules right over here. Yeah. Right? Yeah. It starts off really easy. Power rule, constants. Yeah. There we go. Have a great weekend, everybody. Nothing you need to do for me. Nothing you need to submit. I will see you Monday. Have a good one. If you're going to prom, have fun, be safe, come home back here. Thanks, guys. What's up, Rach?
I was wondering about the
So did you try any of the extra credit stuff? Okay.
Yeah. Nice.
That's great. Do you want more of stuff like that, or do you want more stuff exponential logs? Okay.
Because I get the rule of I'm still not sure when.
Yeah, that's the tricky part. Yeah. Yeah, I can see what I can put together for you. Sure. Yeah, you're welcome. What you got, Siggy?
It's in the sandbox.
Good.
So the first
What's up,
question, I made 3 points. Like, that's one.
Cool.
All the way down.
Cool. Sweet.
I'm gonna figure out the you're given this here.
Yeah. You have the 8, so you can do it.
You're given this hand, which goes the best trade out.
Sure.
And so,
Oh, you click, okay, 3.
so you would like
It sounds like you're saying like 3, like, I'm going to trade in 3 spades, not the 3 of spades. That's okay. I'll
in this hand, go with her first, which one would be the best traded on.
Okay. Or you can say which ones would be the best. You can like switch it.
What's in this hand?
Cool.
You and me are playing cards.
Ooh, nice, cool. Nice. Tricky. I didn't see it at first. That's right.
I made that first one 8 for 3 points.
Awesome. Cool. So yeah, just add the question. Just to be different, just have a different kind of question. Hey Flo, what's up, bud?
What's up?
How we doing?
So good.
I'm so glad to see you.
What's the plan for today?
Plan for today is we'll do a little reflection on our 5-card draw experience. You can take one of those. If you want some Permal, it is good.
Is it?
It is
I saw it
amazing.
being made.
Oh
It's
my
fresh.
goodness, it is.
Did your wife make it? Or was it
The
her
other
father?
global class did, yeah, Miss Einstein.
Was that really global?
Thanks, global. It's global.
Yeah.
She was my long-term substitute for world geography. Can I have one of those?
You remember
World Geo?
Yeah, may I have one of those?
Love Miss Oxenbine. She was my homie. She still is.
You know, my cousin.
Have you talked to her?
I
I
haven't talked to her.
texted her over quarantine.
I should text her. Did she answer you back?
Yeah, at like
That's awesome.
11 o'clock that night.
Oh, Dot. Love Dot.
She had such a weird schedule, but she was so sad.
She's a
because-
night owl, I think. Isn't she a little bit?
Yeah, yeah.
She stays up and watches all our Avs games
She
and Nuggets
actually,
games.
she just sleeps whenever.
Listen, she's
But
living her
her
child life.
son, her daughter-in-law, I guess, works at a hospital, and so they said absolutely not, no visitors, nothing.
Yeah.
And so she was having a really hard time.
Yeah, being pretty lonely. For sure.
All right, well, that's good to go.
Sweet. Thanks, Siggy. We should probably log into our Google Meet.
Favorite.
Really?
I'm
I'm still recording. If you're still watching this, see you.
Can I go run?